Welcome back. Today we have the shortest lesson we will have, hopefully the easiest lesson we'll have, as long as you understand the 3-1. If you don't understand 3-1, you're going to be in a little bit, or 11-1, you're in a little bit of trouble. But if you got the last section and you understand what's going on, sorry about that. If you got the last section, you understand what was going on, this section is going to be pretty good. What this is transformations, and we know how much our book loves to do transformations, and they slide everything. And so this is just one more of those transformations. When you add a constant to every data value, so kind of like if you were taking a test and the teacher gives everybody a 20-point curve, or you know, as things go. So the mean, the median, and the mode. Sorry about that. My music started going a little crazy. The mean, the median, and the mode of the new data set can be obtained by adding that amount. So the mean, because if I add 20 points to everybody's exam scores, then everybody goes up 20 points. The range and the standard deviation don't change when you add to all the data points. They remain unchanged. Okay? So let's take a look at that. We got a midterm exam here. We got midterm scores for a science test or something. It says the data set is given the midterm scores for a chemistry class, and here they are. All right? And if you did all the math like you did in the last section for this information, you got 90 for your mean, 90 for your median, 93 for your mode, 15 for your range, and 4.8 for your standard deviation. If every student in the class has also completed a bonus assignment, so the teacher added 5 points to everybody's assignment, well, that's going to mean the mean goes up 5 points. The median, the middle number, is going to go up 5 points. The mode's going to go up 5 points. But the range does not change, because if the scores went from, if we look at my range here, it looks like the lowest score here was 84, and the highest score here was 98 maybe? Oh no, 83 is the lowest score, and 98 is the highest score. So if I did 98 minus 83, that's where I got my 15. But if I added 5 points to that, well, this guy got a 103, and this guy got an 88. Well, 103 minus 88, still 15, so it didn't change. And standard deviation won't change either. The way your data is spread out wouldn't change. Now, if you multiply your data points, then that will change everything, and everything will be multiplied by the same number. So if you said, I'm going to take those tests, and you know what, we're just going to give everybody 2 tests worth, we're going to double everything, it would double all of these data points. All right, so let's take a look at that. The Olympics. The data set lists the winning distances in meters in the Olympic javelin throw from 1968 to 2004. Find the mean, median, and mode range and standard deviation of the distances in meters. Now remember, look at the little, there's a calculator video that you can link on, calculator tool right on the thing that will show you back how to do this. So if you back out of this page and click on it, I'm going to put it in section 11.1, which hopefully you'll know about in 11.1. But if you didn't know about it, go back, click in it. What we're going to do is we're going to go to Stat, and then we're going to go to Edit, and we're going to clear out that list, and we're going to put everything in List 1. And so if we put all of these data points right here into List 1, and we do, we'll go back to Stat, and we go to Calculate, and we calculate one variable statistics. When you calculate one variable statistics, it will tell you a lot of these numbers. Now, it will tell you the mean, it will tell you the median, and it will tell you your sigma. and so you'll have all those numbers for you. So when we did this, the mean of this was 20.87. That was the average javelin throw. The median was 2080. That was the number that was right in the middle. The mode, 2056. Two people threw the same amount there, right? 2056. But it's possible that no two women would ever have thrown the same amount, so you could have no mode there, right? The range, when you subtract them, is 2.82. And the standard deviation was 0.89. So not spread out too much. I mean, it's like, less than a meter apart. Now, if I wanted to convert all that from meters to yards, I would simply multiply all of those numbers times 1.094. And so if I multiply every single number, because when you multiply, you're going to do all of them. When you add, you only do the first three. Okay, 2275, 2249, and all I'm doing is multiplying these numbers out. 3.09, multiplied it, and 0.97. So about a yard difference. Okay, you go ahead and pause and do the checkpoint and try to do the calculator thing where you put it all in your calculator and see how you do. All right, that was the buzzer. All right, let's take a look. The data set that gives the height in inches of patients visiting a doctor's office. And so you have, these are all the different people who visited the office. After the patients leave, the doctor realizes that all of the patients were wearing tennis shoes and must subtract 1 inch from each patient. Find the mean, median, and mode of all of these things. So with shoes, do all your data points, then without shoes. Now, somebody out there is saying, well, Mr. M. Matt, why wouldn't I just do the without the shoes? Why do I have to do both? Well, you're probably right, but let's do them anyways. Or let me give you the answers anyways. With shoes, your X bar was 66.9. So hopefully, without shoes, 65.9 X bar. Okay, so let's do with over here, and I'll do my without right here. Okay. Your median was 68, and so over here it's going to be 67. Your mode was 68, and so over here it's going to be 67 again. Now the other two will stay exactly the same. Your range will continue to be 16. Range will be 16, and your standard deviation will be 5.1. That's all. Okay. And then it says, from example 2, the mean, median, and mode of the range and standard deviation of the distances in feet. And so what I would do, I wouldn't do 1 meter times 3.28. What I probably would do is I would just multiply all of the yards that I already have times 3, because I know there's 3 feet in a yard, and it might be a little easier for me. But if you multiplied all of those things are 3.28, or multiplied the yards by 3, you'd get 68.45 for your X bar. You would get 68.22 for your median. Your mode would have been 67.44. These are all in feet. And your range would change. Range would be 9.25, and your standard deviation would be 2.92, your sigma. All right, thanks a lot, guys. That was 11-2.